All right, so hello everyone. If you're seeing this, it should be Tuesday, September 21st. This is the study guide, what we're going to be going over for the quiz on Friday. So I do have a study guide up here, all this kind of stuff. Basically summing up what we've been through, what we've been talking about, and then we have some practice problems. So expect similar questions that I'm showing here, and then I'm going to go through on the actual quiz. There's going to be a few more questions on the actual quiz, probably one or two, that I just don't want to really give away. Um, but they should be simple, as I believe so. Um, so what I'm going to be doing is going through them all, just showing you my thought process, what I kind of expect of you when I say some of these answers. Um, this is going to be a live, like I'm doing this kind of live. I'm not going to be taking takes. Like I don't want to have to record this 3 or 4 times. So yeah, we're gonna see how this goes. Um, and if you like this format, let me know. Um, it's something that I wanted to try just because we don't have the necessary in-class day to do this for a quiz. For tests, we're going to spend at least a day or two, preparing. So let's start. The first is which of the following is an example of a compound? So I think I have the ability to draw on here. So what I did here is we have iron, salt water, oxygen, and carbon dioxide, and we need to figure out what is a compound. Now I have a pen here. So I gave these pictures. I think I can. What can I do here? I'm sorry, I'm learning this too. I can do clicks, highlight my clicks. Where am I clicking? So we can see kind of what's happening. So here's the iron, and as we can see here, these are all the same type of atom, right? They're all gray dots connected to one another. So when we see a bunch of the same type of atom, we know that that example is of an element because it's the same type of atom. All of these atoms are iron atoms. There is no iron atom and a different type of atom. So we know that this is not a compound. And I'm going to make this clear on our quiz of some way because I realize that there won't be a color when I print out the quiz. So I'm going to make this clear that this is all the same type of atoms, etc. This is B is salt water. We can see right here. Salt water is, let me see if I can use a pen. Okay, so salt water is this salt getting mixed into the water. And I kind of said it just right there. We putting the salt water into this water and kind of stirring it around. That salt does not disappear. It still exists. It's just kind of dispersed and dissolved throughout the water. That's another of those things that we're going to talk about why that happens. It's a reoccurring theme, but we are mixing together the salt and the water. So this would be a mixture, right? So when we put the salt into the water, they are not forming a new compound. There are no bonds being created. They are coexisting together equally. So we could see it as here is the water and then the salt. They're coexisting. This is, I should use different colors here. Use this blue. Oh, this is actually, we'll use green for this. And we'll use red for here. This is a very rough approximation. We're going to learn a lot more, but just note that we have the salt here and the water, and they're kind of chilling, right? They are mixing together, but that does not make this connection, right? So this would make it a compound, but because that is not there, this is a mixture. Oxygen, this is the same type of atom. Again, this is an oxygen atom, right? And so oxygen, and this is an oxygen atom. I will make this more clear on the test, or the quiz, excuse me, just because we can't see colors. Generally, the same color has represented the same type of atom. We can't really see that on the quiz, so I'm going to indicate that somehow. So this is again, just like the iron example, the same type of atom over and over. So this is a pure element. And finally, with carbon dioxide, we have oxygen as an element. We have carbon, and we have oxygen. So we have two different elements, carbon and oxygen, two types of atoms that are connected. We can see the connections here and the connections here. Because of those connections, this would make carbon dioxide a compound. And our answer is D. So if we're writing why that this is a compound, it is because two or more elements. You know what, let me see if I can type this. I want this to be as clear as possible. Let's see. You know what? Here's what we're gonna do. We're just gonna clear, and I think I can just type in here. So, just to make this clearer. Why? So we have two. When you do this, you'll be writing in here. I'm just gonna be typing two different elements, carbon and oxygen, are connected together by a bond. Right? So this is what makes something a compound. We have two different elements that are connected, two different types of atoms. Well, this Y section is going to be on every single one of these answers. I'm only looking for a very short answer. I'm not looking for a 5 paragraph essay. I'm not looking for even a paragraph. This can be a sentence. I want to make this clear. This Y, a simple statement, right? Two different elements, carbon and oxygen, are connected together by a bond. That tells me that you know that a compound is something where you have two different elements that are connected together by a bond. That's all I am looking for. Okay? No need to write too much. That simple. So, discussion 2. For dinner tonight, I made a salmon salad by combining canned salmon, mayonnaise, soy sauce, garlic, and salt together. This is true. This was my dinner tonight. It tasted good. I made a onigiri with it. So, this is an example of a mixture, element, compound, or gas. So we have a whole bunch of stuff that I'm putting together. So I'm not making anything new. I just put a whole bunch of stuff together, and you can see with the whisk right here, I put them together, and with what a whisk does, I combine them, I mix them. So I did not create a new compound. I did not add bonds to any of this stuff. I just put it together and I mixed it. So it's not an element because there's a whole bunch of stuff, right? Salmon is very different than mayonnaise, right? And soy sauce, garlic, those are all different compounds. Those different compounds in some of those. Mayonnaise has a whole bunch of different ingredients. So it's definitely not just a single element. And it's not just a single compound because there's a lot of different compounds that I've put together and mixed. So this would be a mixture because, all right, let me go back to typing in here. Put a lot of different ingredients, mixed them together. There are multiple compounds together without making something new. Move this out of the way so we can see this answer. All right, simple. One sentence, 1 to 2 sentences. Number 3, draw a compound. Use different shapes to represent different types of atoms. So what this means, I'm saying here, is we've been representing atoms by different colors. That's why I'm going to have to change that when I make this quiz and print it out and copy it. So you could do something like what I'm going to do over on the left. I'm just going to use black pen. So this equals a triangle equals one element, a different type of atom, element 1, and a circle represents element 2. And I'm going to need this from you. To get full credit on this question, I need a scale. If you just, some kind of what everything is. If you just write and draw me something, I need you to kind of explain, just give me what I'm looking at. So when we draw models and we draw representations, you need some kind of scale. You need to tell me what everything is. Without that, I can just see a bunch of different shapes connected. So to draw a compound, we know that a compound is two or more elements of a different type, so different types of atoms, elements, that are connected via bonds. So all we would have to do, the very simplest compound we could draw would just be this. That's it. That's all you would need right there. You could have fun with it. You could do something like this. You could do something like this. You could add on to it. You could make a whole new shape, but you make sure that you say is a different element. All right, nice and simple. Let's clear this. We're going to scroll down. So now we're kind of getting onto the phase of matter questions. So following structure indicates that this is a solid, a liquid, or a gas. So what we see here is a reoccurring theme. It kind of looks like a pyramid. We can see that there's only one atom, there's only one element. It's all these green dots, so they're all the same. So we know it's just one element. But that doesn't mean that it's a solid or liquid or gas, right? You can have a solid or liquid or gas that can be a compound. But we notice that it's in this geometric shape. It kind of takes this almost like a little house, where you have a center in the middle. It's reoccurring and there's a pattern. So when it comes to that reoccurring pattern, this would be a very structurally sound structure. This thing is rigid. And we know that something that has this rigidness is going to be a solid. So when we write Y, we write there is a strong structure that is rigid and a reoccurring geometric pattern. We see this pattern over and over again. So this would be a solid. If this was a liquid, you would not have this structure. In a liquid, you would have the atoms. In this case, this is not a compound. You would have them. I'm going to get a different picture of them just to show you. Let's see, how does this work? You'd have something like this. This is a liquid. You can see how there's no shape in the atoms, right? There's no definite shape. They don't take a pattern. They're kind of all random around. All right? Whereas the solid has this pattern. Now, just for fun, this is the structure of a diamond. This is a diamond. This structure, this is probably, as you know, diamonds are some of the hardest materials that we have. So this structure gives this diamond so much strength that it is almost impossible to break it. It's one of the hardest materials that we know of. Oh, I should have also mentioned, if this was a gas, you would see maybe two atoms. The atoms are just floating around. They're not interacting much. All right. So, number 5, complete the chart. So this is, does it take its container or is it constant? I'm going to explain this. So this is kind of important because I feel like I could have worded this better, but we're going to go with what we got. So what I'm saying is the shape, does the shape take its container or is it constant for a solid, a liquid, and a gas? And does the volume take its container, fill up its container, or is it constant for a solid, a liquid, and a gas? So a solid, the shape is constant. I apologize if you hear any Facebook noises. Let me get rid of that. I'm still I'm still learning how to use Screencastify. It's my first time doing it. Hopefully this goes well. So a solid has a constant shape. Just if you can see me down here, this pen that looks like a Twizzler, the shape of this is constant. It does not change. It's hard to change it. I could snap it in half, but that would require a lot of effort. A volume, this pen has the same volume. It takes up the same amount of space no matter which way I hold it. So how much space it takes up is going to stay the same unless you radically, if I snapped it in half, but that's again a very radical, takes a lot of effort. So this is also constant. In a liquid, the shape of a liquid does not stay constant. Here we have a liquid, hand sanitizer, and as I move it around, I'm going to hold this up to my webcam, the shape of it changes. We can see how the shape of it is changing as I move it around. However, the volume stays the same. So you can see that there is, it's hard to see. At the top here, there's a kind of, an air bubble, because I've used some of this. This amount of space, if you were to put it in a number form, which we're going to do, is going to be the same no matter how you hold this bottle. So a liquid, the shape takes the form of its container, but the volume, how am I running out, is constant. It does not change. And finally, we have a gas. With a gas, I'm going to think about the balloon example again. You fill up a balloon. As the balloon gets bigger, the gas that's inside takes up the shape of that container. The shape of the gas is the inside of the balloon. The volume of the gas, how much space it takes up, increases as you make that balloon bigger. When the balloon is this big, let's say it's this big, the space would just be this circle. But as you keep blowing air into the balloon and it grows to be this massive, now the volume, how much space it takes up, is the bigger balloon. For a gas, shape and the volume are the container. Okay? Sounds good. All right. So, question 6. This question is not going to be for regular. So this question is going to be for just the honors and scholars. For those that are in regular, I just wanted to make sure that we got through everything. Um, I'll gladly go over what viscosity means, if you want to reach out to me, but we're just going to keep it simple for now. Okay? So viscosity is defined as a liquid's ability to flow. So think about something pouring again. like I have this liquid here, as it comes out, it's just going to show up on camera. We'll find out. As it comes out, right, it's flowing down into my hand. The higher the viscosity, the more difficult it is for a liquid to flow. So a high viscosity means it's hard to flow. Think about honey. Think about syrup. Think about the pitch that we saw in the experiment. They have high viscosity. Excuse me. Something that has a lower viscosity is easier to flow. So like the hand sanitizer or water. So what I'm looking at for this question is the time it takes for a droplet to form. If you put this liquid into a funnel, how long does it take to form a droplet that will drop? So one of them goes for 5 seconds. The other one, it takes 5 years to form a droplet. So if it takes less time to form a droplet, it's flowing faster, right? It's making droplets faster. It's flowing faster. So this would have a lower viscosity. If it takes 5 years to form a droplet, right? Think about the pitch that took 10 years. It is a very, very viscous material. It does not flow very fast, which would mean it is very viscous. The answer would be liquid 2 because it takes so much longer to form a drop and to flow. All right? All right. So, last two questions. So, question 7 is the following an example of a physical or a chemical change and why? So, right here we have two compounds. We know that, well, we have two elements. Let's backtrack there. I'm catching myself making some mistakes. We start with two pure elements and we end with two compounds. Again, I will denote that these are different elements, most likely with shapes, and I'll make a key myself. Um, that's something I should kind of do, so we'll do it just for this. This equals element 1, green equals element 2. So, we start out with a pure element, and they're connected, element 1 and element 2, and we end up with two compounds. A compound that has one atom of element 1 and one atom of element 2. So, we started with bonds here. Back to clicking. Bonds right there. We ended with the bonds in a different place. So because we started and ended with different materials, different substances, this is a chemical change. A chemical change is what happens when your before and your after, you create different compounds or different elements than what you started with. And I say create, I'm saying that the bonds are changing their location. You cannot create something out of nothing, right? All the atoms that we start with are going to be there afterwards. I want to say that. I'll formally go over what that means again later. So, the bonds have changed. We started with two pure elements and we ended with compounds. So, because we started and ended with two different things, this is a chemical change. So I'll write it in. Started with just pure elements and ended with two with a compound, we'll just say, because it's two versions of the compound. Ended with compound. So there were bonds between atoms that were broken and formed. Right? So this bond between the two red atoms was broken. It's not there anymore. Oh, okay. So this bond was broken. This bond was broken. There was a new bond that was formed and a new bond that was formed. So when the bonds like this are broken and reformed, that means something new is being created, right? We have a new compound, and this indicates a chemical change. What are these other? Oh, it's fireworks. All right. We'll just do highlights. All right. So, last question. In order to make a spaghetti dinner, I put a pot of liquid water on the stove and turned it on. Eventually, I started noticing a vapor of gas form, right? If you've seen this like smoke, there's a lot of bubbles and you can see smoke come out of your pot. Is this a chemical or a physical change? So, what I'm trying to get at here is we started with liquid water and we ended up with gas. So, this is a phase change, right? This is vaporization. So, what we're seeing here is vaporization. We are seeing the liquid turn into a gas. Because of this, we have the same substance. We have water in the pot, and then the temperature increases, it boils, and it becomes a gas. So, before and after, it is still water. The same three atoms are connected. We have the same compound. So, because of that, it is a physical change, right? So, we start and end with the same compound of water. Only the structure changed. The structure changes when you change phase. I'm going to pull in another image here. Let me open this up. Right, so here's our example. I'm going to just scroll down here. All right, so here in the liquid, this is our liquid. Each one of these is a water compound, right? This is all water. And we can see in the gas, the structure has changed. There's not as many of them. They don't really interact with another as much. So we changed the structure, but not the compound itself. This looks the same as this. So it is a physical change. The bonds are still intact. We could draw that out. How do I go back? All right, here we go. Right. So I'm just going to use, we have red and white. Here's our before. If we just took one compound, one molecule, I'm going to use that word. We're going to get back to the formal definition, but this is a molecule. And we go to the after, we still have the same thing. So this is a physical change. So I hope that this was helpful. I'm going to clear this. Again, all the notes and such are up at the top. There's going to be probably a few questions that are just kind of extra. I'm not going to, I didn't go over them because they should be on the easier side. This is going to be 20 points. All right. This is the first quiz. It's going to be okay. We're easing you back into the year. All right. So good luck. And I have to figure out how to end this. Your tab is all right. And it's right just about 30 minutes. So, good luck, everyone.